recording. Yes, Jonathan. Okay, we talked about that. What does it mean uniform width, you guys? Yeah, it means the same all the way around. That means the distance away from the wall is going to be the same all the way around. I mean, as far as the, like, if you draw a picture of a room, let's say this is the room. Okay. Then here's the rug. That means the distance. That distance is the same as that distance, is the same as that distance, is the same as that distance right there. And this is the rug is 1/2 the area of the room, right? Has anybody got an idea on how we can write an equation that would model this? Okay, this is what mathematics is really about, you guys. If you can figure out this kind of stuff, this is what makes math a little bit more fun to do, and because you have to think, it's not trying to memorize something, you have to think about something right here. But everybody, what's the area formula? Again, one more time, for a rectangle. Length times width, right? So area equals length times width. There is the model that you're going to use. Now you're going to make some substitutions. Okay? We're going to make some substitutions in here. You want your new equation to be how much of the original area? 1/2 the original area. So we can do this. 1/2 of A equals, and think about this. What are the dimensions of the room? Okay, 12 by 16. We'll put the longer one as 16. Okay, and so if you have a 12 by 16 room, what's the length of the rug compared to the length of the room? What? How long is this length compared to this length? No, the area is 1/2. But do we know what the uniform width is, you guys? Do we know what our uniform width is? What is it? We don't know. So what are we going to call it? X. You guys, this is X. This is X. This is X. And this is X. Okay? So, think about this. How is this right here compared to this length right here? We don't, but we can write an expression that represents it. What's the expression we could write that represents that length? What? Not 12 equals X. 12 does not equal X, does it? It has something to do with 12, and it has something to do with X. It's an expression, not an equation. Watch this, you guys. Look, right here. How long is this distance from here to here? How long is it from here to here, you guys? X. How long is it from here to here? No, we don't know. How long is it from here to here? Okay. Well, the distance from here to here is the expression of this much right here, this outside 12, minus that X and that X, isn't it? So what's an expression I can write? 12 minus 2X. I'm going to say that's the width. W equals 12 minus 2X. It's the length, or the width of the room, minus the 2X's that we cut off the ends, right? So what's the length of this rug right here? 16 minus 2X. So now we have a length is equal to 16 minus 2X. Can we substitute those into the equation? Okay, we know the area is 1/2 the area of the original is equal to 12 minus 2X times 16 minus 2X. Do you guys understand that? Okay, now do we have a function? So this is saying right here, 1/2 of the area of the room, 1/2 the area of the room, is equal to the width of the room minus the 2x's times the length of the room minus the 2x's. Okay? So 12 minus 2x and 16 minus 2x. There's my equation. All right, so now we're going to move up here. We are going to move up here, and we are going to, we're going to do, what can we do to this equation to get a by itself? Half everything? Thank you. Times everything by 2. They cancel out. So we have area. We could call it a of x, couldn't we? Area as a function of x is equal to 12 minus 2x times 16 minus 2x. By the way, we know what the area is going to be, don't we? Yeah. How can we figure out the area, you guys? Well, 16 times 12 is going to give me the area of the room. What is 16 times 12? Put it in your calculator. 192. But we know the area of the rug is going to be what? Half that. Someone tell me what that's going to be. 96. Okay. So now we have 96 equals 12 minus 2x times 16 minus 2x. Right? Oh. You know what? The bottom equation wouldn't require it because what we did is we already took the half of the area. So I forgot about that. I could have written it right here. But we'll write it right here. Since we knew that a of x is equal to 192, divided by 2 is 96. Okay? I'm sorry, that kind of confused it right there. Okay, do we know how to solve equations like this, you guys? We do. What kind of equation is this? It's a quadratic equation. How can you tell it's a quadratic equation? Because you have these x's, once you times them together, you're going to have an x squared, don't you? We need to multiply them all out. So let's go like this. 96 equals 12 times 16. What's that again? 192? Times 12 times negative 2x is going to be negative 24x. Negative 2 times x is negative 32x. And negative 2x times negative 2x is positive 4x squared, right? Okay, we're going to minus 96 from both sides. And we're going to combine like terms, and we're going to get 0 equals 96. What's negative 24 minus 32? Okay, negative 56x plus 4x squared. Okay, now we have a quadratic equation to solve. We learned 3 different methods, and we talked about a 4th one of solving quadratic equations. What were the 4 methods? Graphing. What's another one? Quadratic formula. What's another one? Factoring and completing the square. Those are the 4 methods, right? Which one would you guys like to try with this problem? You know what? I just noticed something. All 3 of those terms are divisible by a certain number. By 4, actually, right? 4 will go into all 3 of those. So we can divide both sides of this equation by 4. And so that's going to make 0 equals, what's 96 divided by 4? Huh? 24. What's 56 divided by 4? 14. So minus 14x plus x squared. That actually makes it, we could check to see if it's factorable now, can't we? Or you can do it by graphing. If I wrote it differently, x squared minus 14x plus 24, does that make it look easier to try and... What are 2 numbers are there 2 numbers we can time together and get 24 and add together and get negative 14? 12 and 2. Negative 12 and negative 2, right? So we're going to go like this. X minus 2 times x minus 12 equals 0. Therefore, what are my x-intercepts? X equals 2 and x equals 12. Now, one of these answers will work and one of them won't work. Anybody tell me which one will work and which one won't work and why? Huh? Why? Think back to the story problem, guys. What was that, Sadie? Isn't the one side 12? What does that have to do with it? Let's look at it. You guys see a problem there? If we made the uniform width 12, by the way, what's the most the uniform width could be? And still have a carpet in the middle. 6. Why 6? It's half of 12. I mean, if you had the uniform length of 6 on this side and 6 on this side, you wouldn't have any carpet, so it'd have to be greater than 6, right? But a small one like that would have a thin strip. But 2 makes sense, right? So 12 we can throw out, but 2 makes sense. And so, did I answer the question yet, you guys? What's my answer? What are my dimensions of my new rug? Well, what do you think? Two times 2 is 4. 12 minus 4 is 8. It'll be 8 by 12, right? Okay. Hey, by the way, you guys, this is what mathematicians do when they have a thing. This one actually could have been solved by guess and check really easy, if you think about it. You could have figured out first of all what the area of the room was, and then all you would have had to do is divide that in 2 to get 96, and then find 2 numbers you can times together and get 96 that would work, right? You did do that? Okay, good. But I did want you guys to see that you can model this problem using an equation, okay? So that's what I wanted you guys to see by doing this problem right here. Does that make sense? We'll see, Maddie. Just watch the video, okay? We'll see you. All right. So, hi, Julia. Yeah, she's heading out. Okay. Okay, so we got that? All right. Now, okay, which number? Okay, we're going to go over problem 37 on the assignment. 37. What does it say? What does it say, McKay? It is a big story problem. Okay. Okay, number 37 is a story problem. It says, in an action movie, a stunt woman jumps off a building that is 50 feet tall. Okay, let's draw a picture of that. A building which is 50 feet tall. You guys ever seen my good buildings I can draw? I am like really good. I'm really good at buildings. Is that a good building or what? Mikhail, I'm an artist. You got to give me encouragement here, okay? I'm at my artwork where you guys are at with your math right now, so I need some encouragement here, okay? All right, so what did you say, Andrew? Okay. Okay, so hey, these might be 12 and a half foot floors. Okay. Hey, huh? Hey, by the way, I watched the movie Man on the Edge. Anybody seen that movie before? I watched it this weekend. Movies? Okay, anyway, it reminded me of that when I saw that up there. Okay, now, you guys, it says a stunt woman jumps off a building that is 50 feet tall with an upward velocity of 5 feet per second. Okay, in other words, she jumped up first, right? The distance d of t traveled by a free-falling object can be modeled by the formula d of t equals v sub 0 t minus 1/2 gt squared, where v sub 0 is the initial velocity and g represents the acceleration due to gravity. The acceleration due to gravity is 32 feet per second squared. You know what? This equation actually gives you all the information, even gives you the equation. It's not like the last one where I had to, we had to come up with the equation. So someone tell me that equation again. What does it say? V sub 0 equals? What's the equals part? It's what? G of t? D of t? Yeah, because it's talking about distance, right? D of t equals the initial velocity v sub 0, t, minus 1/2 gt squared, like that. Okay, now, v sub 0 is the initial velocity. What does it tell us the initial velocity is? 5 feet. So she's up here on this building. She's a stunt woman, keep in mind. And so she jumps up first, and then she starts falling, right? Okay, now. Huh? All right, tramp. Yeah, it's a pull. All right, so it tells us the initial velocity, right? And v sub 0 stands for the initial velocity, right? What is it? 5 feet per second. So it's 5. So we're going to say 5t minus 1/2. And g, what does g represent? It represents 32 feet per second, right? So we can go 32 t squared, right? It gives us all the information. It tells us what the initial velocity v sub 0 is. By the way, you guys, anytime you see a 0 written below like that, that's a subscript. You guys all know what a subscript is? What does the word sub mean? Below, right? And so we call it v sub 0. Sub means subscript. It's just a short way of saying subscript. V sub 0 is one variable all by itself. You're going to see this a lot when you guys get to calculus. You'll see V sub 0 or something like that quite often. And it's all one variable. And if you know what the value of it is, like we do right here, it's 5, then you can just substitute it in there. Okay? You'll see 32 feet per second squared as the acceleration due to gravity a lot too, because that's what it is. And so usually gravity is 32 feet per second, and you'll get a problem like that. Okay, now, it asks us to do a couple of things, right? A, draw a graph that relates the woman's distance traveled with the time since she jumped. Okay, so we're going to make, by the way, we only need the first quadrant. Why do we only need the first quadrant? Because what? You're not going to have negative time or negative distance here, right? Which one's going to represent time? Which one's going to represent distance? Distance? Think about this. Which one's the independent? Which one's the dependent variable? Time is independent. And which one do we always put as the independent? Yeah, x. So time is the dependent variable. So we're going to go 1 second. And it wouldn't make sense that it's going to take seconds, not like minutes or something like that. So we're going to go 1 second, 2 seconds, 3 seconds, 4 seconds, 5 seconds. If it goes more than 5 seconds, I'd be surprised, okay? So here's the time in seconds, 1, 2, 3, 4, 5, and so forth. Okay, and then we have height in feet. How high was she initially? So 10, 20, 30, 40, 50 is going to represent that time right there, okay? All right. So it says, part A again says, draw a graph that relates the woman's distance traveled with the time since the jump. Okay, so let's let's put this in our calculators. Everybody take out your calculator. And we're going to put this in our calculators. Okay, there is no reason anybody shouldn't be putting this in their calculator. None. Everybody should put it in their calculator. So get it out and let's do this. Okay, 5x minus, by the way, what's 1/2 of 32? 16. So we can just put that in as 16 times x squared, where x represents the time. And we can hit zoom 6, so we all start off with the same window. What's the problem with zoom 6? Wait, something's wrong with this picture. Huh? Wait, let's bring this in a little bit. Let's go from -2 to like +3. And we can leave that as -10. Well, let's look at that, see what that does. Wait, something's wrong. Does your graph look like mine? Did I forget something? All right, let me look at this problem. Okay, it says draw a graph that relates a woman's distance traveled. Oh, I know why. I know why it looks like this. Because they're counting this where she jumps off the building. So we actually need the bottom part of this graph right here. Because they're talking about the top of the building as being 0. So down here, we're going to go down to 50 feet below. So that's going to be 10, 20, 30, 40, 50. Okay, so this is -50 right here. That's what it's doing. Okay, so that's our graph, right? And we're going to have to change our window. So we're going to have to see that this is 50 feet below. So we're going to have to go that to -60. Should we go -60? And let's change that to maybe to 5. And we're going to change the x scale, the y scale to like every 5 units. Okay. All right. Now we graph it. Okay. We can pretty much see the whole graph now, right? If you're looking at that, can you see about, if you're looking at the time, looking at the graph right there, how long is it going to take her until she hits the ground? A little over 2 seconds, because this is 1 second. 2 seconds, right? She hits the ground a little over 2 seconds. Does that make sense? Oh, except for, I think, I went to 60, didn't I? Let's do this. Everybody go to your y equals. Let's put in -50. So we'll put in a horizontal line at -50. Y equals -50. And where those two intersect is about where they cross. So it's right around 2 seconds, give or take a little bit, right? Okay, let's see what the questions say. Part B says name the x-intercepts of the graph. Okay, so we could look at the x-intercepts up here. What do they look like about? Zeros, right? We're looking for zeros. I'm going to go get this left one right here. My left bound or the right one? Here's my right bound. And about 0.3125. Okay, so my x-intercepts are 0 and about 0.331. We'll put 0.31. By the way, how do I know the other one's 0? Well, if you put 0 in for t and t right here, right? The y value is 0. Plus, yeah, we started at 0, right? Okay, so she jumped 0.31 feet in the air. She went 0.31 feet. That's 3 inches, right? Okay, huh? 0.3 is about a third, so 3 or 4 inches, somewhere between 3 and 4 inches she jumped off. Okay? Huh? So she probably went like this. Okay, like that, and jumped off the building, something like that. Okay? She's a stunt woman. Stunt women jump off buildings. All right. Okay. Okay, now it says, what is the meaning of the x-intercepts of the graph? You guys, what does that mean? When she what? When she's parallel to the building? What do you mean parallel to the building? Okay. It represents when she's even. Is that what you mean? Kind of level with the building? Her feet are level. So her feet are on the top of the building. She jumps. When she hits this part right here, she's level with the building again, right? That's what it represents. That's how long it took. Oh, by the way, an X doesn't represent feet. We were misinterpreting it. What does X represent? It represents what, you guys? Time. So it took 0.3 seconds to get to that point, okay? Once you jumped. All right. Okay, D. Write an equation that would be used to determine when the stunt woman will reach the safety pad on the ground. Hint, the ground is minus 50 feet from the starting point. Okay, so what's the equation we would write? We have part of the equation right here, right? D represents the distance, so we'd do what? Yep, that would be it right there. When? Okay, so that would be it right there. All right, and E, how long will it take the stunt woman to reach the safety pad on the ground below? Well, when the two lines intersect is when she's going to be there, right? How can we do that? Do you guys know how we can find that point? Everybody go to your calc menu. Second. And trace button. Which one of those things on there do you think we want? Intersect. Yep. Number 5. We want intersect. And we're going to go down here. Oh, wait. I shouldn't have done that. I'm going to clear that again. Second. Intersect. What I do is I just need to go close to where they intersect. Right there. And just hit enter. And since it's close again, I hit enter. And then I make a guess. Because it asks for first curve, second curve, and then the guess. Okay. Can we tell? How long did it take until she hit the ground below? 1.93 seconds. So time equals 1.93 seconds. Doesn't take very long to fall 50 feet, does it? Okay. All right. So if you jump off a 50-foot building, take less than 2 seconds before you die. Unless you have padding below there, right? Huh? Okay. I always thought the worst kind of death would be falling off something really high and knowing you're going to die as you're falling. Oh, drowning might be worse. Okay. Suffocation would be bad too. Yeah. How tall is this building? I don't know. If I was guessing, I would say the part we're in right now. I'm guessing it's probably about no, I don't think it's that tall. 40 or 50 feet is all. Well, if you think there's 3 stories, and each story I think is about 10 feet because how high do you think that ceiling is right there, you guys? Bryce, jump up. Touch the ceiling. See if you can jump. Ooh. Okay. How high do you think that is? 9, 10-ish feet? Well, if you push these things up, there's about a crawl space 2 or 3 feet. So let's say this was about 12 feet on each floor. 3 times 12 is 36 feet. 36 to 40 feet, I'm guessing. That's how tall this building is. All right. Okay. Is there another question you guys want to know about? Lydia, 26? What do you mean? Lydia wants to go over 26. You do? Okay, what is the conjugate of negative 7 minus I square root of 5? Oh, this is the easiest question ever right here, you guys. How many of you know it? Negative 7. What is the question again? Negative 7 minus I squared root of 5. There's only one thing you need to change to get a conjugate, you guys. What is it? Which sign? Yeah. Make it opposite of what it was up there. I changed that minus to a plus. That's it. Conjugates only differ by the sign in between them. Okay? If you don't have that in your notes, I would write that in your notes. Conjugates only differ by that middle sign. Okay, what else? I'll do one more. You guys all know how to use the quadratic formula. Okay. Okay, I'm going to move on then. 38? We didn't do 38. 39? I did that one. State the number of complex roots of the equation, then find the roots and graph the related function. How many roots is number 39 going to have, you guys? 2, 3. What power is it? It's a second degree. So how many roots is it going to have? 2. Okay, so, and then to find them, okay, how am I going to find them, you guys? What is it? 18 what? A squared plus 3a minus 1 equals 0? Okay, now, so it's second degree, so it's going to have 2 complex roots. This one, is it looking factorable to you guys? 2 numbers you can times together in 18, add together and get positive 3. And you have a negative 1 over there, you can times one of them by, so 3 and 6 might work, right? 6 and 3 and negative 1 and 1. If you went negative 3 times negative 1, that's negative 3. And 6 times 1, that's 6. That adds up to 3. Oh, it does factor. I wouldn't have thought it was going to factor. So this one can be done by factoring. If you don't know how to do it by factoring, which way should you do it? Or graphing? Or if it doesn't do it by graphing, which way should you do it? The quadratic formula. Okay? So this one's going to factor like this. It's going to factor be 6a and 3a. And then 3, this 3 right here, which is this 3, has to be times by a negative 1. So am I going to put the negative 1 over here or over here? In the same one or the opposite one? Yeah, I'm going to put it in the opposite, right? Okay, so that's my 2 factors, and I can set 6a minus 1 equal to 0 and 3a plus 1 equal to 0 and solve those 2 equations, and I'm going to have my answers. Yeah, she teaches a different method. Yeah, I once knew that method. I couldn't tell you if I remember how to do it right now or not. Okay, so I've never liked that method, but if you like that method, go ahead. Okay. And so 1/6 and negative 1/3 are your 2 answers, your 2 roots. Sorry, Rachel. Let me move that for you. Got it? Okay. All right, we're going to move on. Okay, good, you guys. This is due next time. Okay, today, this is not the correct objective up here. Let me. So everybody got the objective down? You review synthetic division and understand the factor theorem. That's what we're going to do today. All right, so synthetic division. You see a problem like this where it's this polynomial, this cubic polynomial, divided by x plus 3. Okay, now, by the way, synthetic division only works under what circumstance? When your divisor is to the first power. Everybody write that down in your notes. Synthetic division only works when your divisor is x to the first power. Write that down in your notes, Jay. Got it? All right. Good man. When the divisor is x to the first power. So, in other words, it's a binomial where x is to the first power. Okay, so you can't do it. If this would have been x squared plus 3 or x cubed plus 3, you can't do. You have to use long division. Okay, this is what we're going to do. To set up synthetic division, we make this thing right here. What number goes out here? No, it's just a number, a single number. Not 3. Not 1. Okay, I want to know what our divisor is going to be. What did you say? No? No, no more guessing. Think about this, you guys. Hold on. Look. Who said that? Lydia. You guys, it's negative 3. Think about this. If this right here, if our factor is x plus 3, x plus 3 equals 0, solve that equation, that would be negative 3. Then negative 3 is our root. You have to use the root, not the factor. Got it? So, yeah, you just take the opposite of that right there. Whatever this number plus that number would make 0. Okay, so negative 3. Okay, so there's our divisor. Okay. Yeah, I didn't like that. If it would have been educated guesses. But 3 was an educated guess, but it was wrong answer. The other ones, yeah. Okay, what numbers go inside here? 1, 4, negative 3, negative 5. And I bring down the first number, and that's how you set it up. Let's see how many of you remember how to do this. I'm going to give you 30 seconds. Go. Okay, when you got it, check with your shoulder partner. See if you got the same thing as them. Sadie and Eric, you guys are shoulder partners. McKay, no imaginary friends. Check with Eric or Ramon. Parker, you same thing. Check with Bryce and Jay. Okay, let's see if you got it right. Here's how you do it. Negative 3 times 1. You times these two numbers together, you get negative 3. Then what do? Yeah, 4 plus negative 3 is 1. Then what do? Negative 3 times 1 is negative 3. Add, what do you get? Negative 6. Negative 3 times negative 6 is 18. Add, what do you get? 13. Guess what? Well, it didn't end in 0. Doesn't mean we did it wrong. It means that x plus 3 is not a factor of this. In other words, it doesn't divide into it evenly. So we have a remainder of 13. And you guys, here's my new expression. This right here is the coefficient that's going to be 1 less than x cubed. Why? Because we divided x to the 1 into it, right? If you go x cubed divided by x, what do you get? X squared, okay? So this is the coefficient for x squared. So it's 1x squared plus 1x plus or minus 6 plus 13 over x plus 3. The remainder over the divisor. Got it? That's the answer. Okay, that is synthetic division. By the way, and 13 is your 13 is your divisor. Don't worry, Easton. I got it. I know how many we're doing. Okay, here we go. Do this one. X cubed minus x squared plus 2 divided by x plus 1. I'm going to pause this for a second. What's my divisor, everybody? Negative 1. It's the I have divisor is x plus 1 right here. In synthetic division, we take the root, not the factor. Okay, the root would be negative 1 because negative 1 plus 1 would make 0. What are my coefficients? 1, negative 1, 0, and 2. Why the 0? How many of you forgot the 0? Why is there a 0 there? Yeah, we had the x to the third power, x to the squared. We're missing the x to the first power, which means its coefficient was 0. Bring down the 1, and you're ready to begin. Don't forget to insert zeros in there. Negative 1 times 1 is negative 1. Add, what do you get? Negative 1 times negative 2 is? Add, you get. And negative 1 times 2 is negative 2. You add, you get. Guess what? This time, x plus 1 is a factor of that polynomial, right? What's my new polynomial, you guys? X squared. It's always 1 less than that. Minus 2x plus 2. Guess what? If I times this by x plus 1, what would I get? I would get x cubed minus x squared plus 2, right? I would get that top. Okay? The numerator up there. All right. I'm going to teach you guys about the factor theorem right here. If you divide a polynomial by a factor x minus r, and the remainder is 0, then x minus r is a factor of the polynomial. Does that make sense, you guys? So going back to this problem, x plus 1 is a factor of x cubed minus x squared plus 2. Why? Because the remainder was 0. That's what it's saying. Pretty simple, right? Okay? Because in your book, this is how it says it, and you need to understand math talk. Okay? Okay. Let's do this one. 2x cubed minus 3x squared plus x over x minus 1. I'm going to give you a second on this one, and then we'll go over it. All the remainder theorem is saying is if you divide a number, like an x minus 1 into this, if you're whatever you come up with, your last number, that's your remainder. Okay? And if your remainder is 0, what does the factor theorem tell us? Then x minus 1 is a factor of it, right? So the question is, I want to know what the remainder of this is, and I want to know if x minus 1 is a factor of it. So we're going to divide this in here. What's my divisor? Positive 1, right? Take the opposite of that. What's my coefficients? 1. 1 times 2 is 2. Add, I get negative 1. 1 times negative 1 is negative 1. Add, I get 0. What does that tell me? My remainder is 0. Therefore, x minus 1 is a factor, right? Okay, what's my new polynomial? 2x squared minus, minus x. 2x squared minus x is my new polynomial. Any questions there? Okay, here's your new assignment right here. Page 226, 14 through 27, all. Write it down. I'm going to turn this off. What was that? You got time to do your assignment. So when is the test? Let me give you guys this thing right here. Today, Monday, what's the day? The 19th? 19th, we did 4-3, right? On Monday, which is the next class we have, the 26th, we're going to do 4-4, I believe it is. And then on Wednesday, that might even be 4-5 we're going to be doing. Wednesday the 28th, I believe we're doing 4-5. Let me look really quickly. I had this all figured out last Friday, and now I can't remember. Oh, you know what? We're not doing 4-4. We're doing 4-5. And then and then 4-8. So we're going to do 4-5 and 4-8. And then Friday, the 30th, we are going to review. And then Tuesday, what day would Tuesday be? In November, there's 30 days, right? So is it the 4th? Is Tuesday the 4th? The 4th? Chapter 4 test. Everybody got that? So that's the schedule. What? 2 weeks from tomorrow, we're taking the Chapter 4 test. Got it? Can I go back to the assignment? Right there is the assignment.